Hello, everyone. Thanks for joining our session. And we are presenting today our Convergent analytics session. I'm presenting the presenters, so myself. My name is Sergey Lukyanchikov. I'm a sales engineer at InterSystems, and my co-presenter today is Eduard Lebedyuk, also sales engineer at InterSystems. Eduard.
Hello.
So we have
maybe let me just say hello to the German audience. Schönen guten Morgen aus dem Studio in Darmstadt, aus unserem InterSystems Studio, und ein herzliches Willkommen zum 4. Tag unseres AI und ML Summits. Ich bin Jochen Scharafin und habe die Ehre und das Vergnügen, Sie durch einen Großteil des heutigen Tages zu begleiten. Und es wird ein wirklich aufregender Tag. Den Anfang machen unsere Kollegen aus Russland, Sergey, ich muss das ablesen, Sergey Lukyanchikov und Eduard Lebedyuk. Sie haben es schon vernommen, die Herren können es kaum abwarten, loszulegen. Und wir werden um 13:30 Uhr dann einen Vortrag hören von meinem Kollegen Amir Samari, der uns etwas über die Machine Learning Möglichkeiten bei der Vorbeugung sogenannter Readmissions erzählen wird. Readmissions, das sind Wiederaufnahmen in ein Krankenhaus nach vermeintlich erfolgreicher Behandlung. Um 16 Uhr geht es dann weiter mit Frau Professor Dr. Susanne Michel von der Charité, die etwas über die ethischen Aspekte vom Einsatz klinischer Intelligenz in der Gesundheitsversorgung berichten wird und diskutieren wird. Während all dieser Vorträge haben Sie, wie in den Tagen davor auch, die Möglichkeit, in der Chat-Funktion Fragen zu stellen, Anmerkungen zu formulieren, auf die wir dann im Anschluss an die jeweilige Session gerne eingehen. Gleichzeitig haben Sie aber auch die Möglichkeit, mit der Networking Lounge direkt Kontakt mit uns aufzunehmen. Sie erkennen InterSystems Mitarbeiter dort an einem farbigen Kringel um den Avatar. Bouncen Sie uns an. Es macht wirklich Spaß, mit den Menschen dort in Kontakt zu treten, und nutzen Sie auch diese Funktion unseres virtuellen Summits. Aber gehen wir direkt ins Thema hinein. Ich kann mir vorstellen, dass nach den letzten 3 Tagen Summit jeder gespannt ist, endlich IRIS und IRIS Data Platform und IRIS for Health live und in Action zu sehen. Und ja, ich würde Ihr Einverständnis vorausgesetzt dann jetzt ins Englische umschwenken und Sie einladen, sich mir anzuschließen, wenn ich sage: Good afternoon, Russia. Good afternoon, Eduard. Good afternoon, Sergey. I just said that I assume that everybody is really excited and curious in seeing IRIS Data Platform and IRIS for Health live and see our capabilities in machine learning and artificial intelligence in production. First of all, I would like quickly to introduce you to the audience. Eduard is a sales engineer and he's specialized in interoperability and analytics, and recently is helping clients on their journey in digital transformation by producing AI and ML projects and innovations. Sergey is a sales engineer at InterSystems as well, with a focus on platform AI and ML offerings. He issues global thought leadership and go-to-market support for a variety of regional teams regarding AI and ML. That's all from me. Gentlemen, it's your audience.
Richtig. Thank you, Jochen, and thanks for that quick introduction. I've been keeping purposefully that slide about Convergent Analytics community all the way during the introduction, so I hope we've been able to take a quick look at it. But just in a couple of words, we have in the space of the overall communities of InterSystems, there is one called Convergent Analytics that is focused on the theme, the topics of in-platform AI+ML and other analytics. So you can see all the links that are available publicly to get closer knowledge of the community itself and of its projects. Today we will be talking about just 3 topics. I say just, but you'll see it will be quite dense, as we promised in the very beginning. We'll briefly go through the requirement for a productive AI+ML platform, how this requirement is seen by us and specifically by the public that are the current members of Convergent Analytics community. We will, second bullet point, we will look at a certain prototype in action that is based on a real project and that highlights the aspect of distributed AI+ML, which is not the only one, but has been selected by us specifically for this session today as probably one of the illustrative of the latest tendencies in this domain of in-platform AI+ML. And finally, we will say a couple of words of how this could be applied to an industry scenario, keeping in mind that this session is taking care in a healthcare stream of the event. So to start with, just several questions that most of us are asking that once we are starting to consider the real-time AI+ML topic. Are we satisfied with the creation and adaptation speed of AI+ML mechanisms in our company? How well our AI+ML solutions support real-time decision making? So real-time, double underline, real-time decision making. Can our AI+ML solutions self-adapt? So can they continue working without involving developers? Can they adapt to a drift in the data, the drift being a natural change and evolution in the quality and also the character, the nature of the data? And can they adapt to resulting decision-making approach changes? So we took a pretty standard diagram, InterSystems IRIS architecture, and we added to the left and to the right certain partner third-party tools that convert all together by interacting with those tools. IRIS can be called a real-time AI+ML platform. On the left side, you see the 3 what we would call universal or all-purpose mathematical modeling environments, Python, R, and Julia, and also 2 specialized frameworks that deliver AutoML, automated ML computations, H2O and DataRobot, both partnering with us and both available and accessible and actually manageable from within IRIS using integrated ML. This topic is quite covered in the course of the event, so you can visit focused sessions from our colleagues to learn more about it. And on the right, you see a collection of development environments starting from our own IRIS Studio in the very bottom. Then goes Jupyter, the specialized editor for AI+ML mechanisms. And then there are a couple of IDEs, Visual Studio Code and Eclipse. And finally, the cloud-based code interchange and version management environment, globally known as GitHub. So all this spectrum of third-party tools is capable of being interfaced with IRIS, and IRIS as the real-time AI+ML platform is capable of orchestrating them. And we'll now start discovering how. If we look at the at our platform from continuous deployment CD perspective, which is the terminology of DevOps, and we are using it here to show that we are sort of DevOps space within IRIS. So you would start from getting some data samples from the platform, stored in the platform, stored outside, but we prefer it to be platform. But anyhow, they become accessible for Jupyter. In Jupyter, your data science teams, team specialists are creating or modifying the AI+ML mechanisms that have to be put together in a solution. They're using for this Python, R, or Julia, and Python, R, and Julia scripts are being manipulated via Jupyter. Once those snippets or once those whole mechanisms are ready for deployment, they can be replicated automatically from Jupyter into IRIS platform. So that's the essence of that first layer of functionality. Then comes what we would call continuous integration. So that's the core functionality of IRIS that allows us, and we provide certain templates to facilitate this, that provides instruments for you to assure the capturing of real or near real-time data, or even static data like master data, for example, in needed volumes at needed frequency into the platform. And the most important point, to convert it into processing queues. The three most important processing queue classes in terms of AI/ML will be the model training queues, the data that is queued into model training process, the model application queues, of course, because the models will need to be applied, and they will need to be applied in real time most of the times, and the queues for monitoring model accuracy. This is something that is serving the purpose of controlling how precise our models, AI/ML models, are functioning. In the end, IRIS is also instrumental to assure the distribution of AI/ML results. So we are distributing, first of all, the model application results, different forecasts, different scoring classification, whatever your solution will be doing. And we would also be distributing model training results, and our today's demo will be built specifically about the aspect of sharing training results with an external data scientist that is curious to audit how his models are functioning in our platform. And the third is model accuracy monitoring results. Also a specific type of distribution that is also data scientist centric. The third layer, which we would call continuous training, CT. CT also means in DevOps terminology continuous testing, but since testing in machine learning is mostly training and validation of models, so we would adopt the translation of CT as continuous training. And here happens probably the most mysterious, but also the most important action. We are converting the currently existing models and data sets into retrained models. We say not trained, but retrained, because we keep in mind that this process is continual. It's a real-time process. It theoretically has neither the beginning nor end. And here come our specialist AutoML frameworks, H2O and DataRobot, that can be added to this continuous training work to serve either as trusted advisors to help us understand how we can improve our handmade models, or even at certain point take it over from the handmade models and suggest their automated modeling as the major version of a modeling stack employed by the platform. So with this quick introduction, so we would like to round up this introduction by saying that InterSystems IRIS is indeed an all-purpose real-time AI/ML platform that is currently employed to automate machine learning and artificial intelligence scenarios for various industries. So we're not limited to a specific industry. We are neither limited to a specific scenario, because as you could see it, we have the full power of our modeling environments, Python, R, and Julia, that help us virtually automate 100–200% of the tasks that could be, in principle, mathematically formulated. So with this, we are going to our practical example, and while I'm presenting the libretto for this example, the example itself is running, because it's supposed to be a real-time solution, and it is a real-time solution, so it's running behind the scenes. But before we go into it, we would like to present just several roles in this example. And the most important role is the prototype itself, which we call factory. And by factory, we mean any real-time data generating processes, starting from classical factories that manufacture something and ending up with something like financials or healthcare, not necessarily associated with manufacturing, but having really heavy streams of data, intensive streams of data that need equally versatile tool set to analyze and to draw decision-making support from those streams. In our concrete example we will be showing here, our factory is mostly concerned with monitoring the developing defects in equipment, trying to predict potential equipment failures or raw material or finished goods quality issues, some human errors and so on. We have two experts, human experts that interact with the factory. There is a data engineer animated by myself, whose most important task is actually to automate the machine learning mechanisms to make sure that the system of various processes in the solution, which we call also agents, that they interact according to specific rules, and this interaction is non-interrupted. Also, the data engineer, he deploys the content that is supplied by the data scientist and embeds those scripts and those models in the framework of an automated solution. Finally, systematically, and that's something we'll be showing today as an example, the data engineer reports trained models and training data sets to the external data scientist, and the data scientist today is truly external. Eduard is sitting in a different location than myself, for a sort of periodic audit and control of efficiency of the modeling pipelines. The data scientist, on his end, he is like the name, the title, the job title suggests, he is developing defect detection AI+ML mechanisms for the productive solution, also modifies the existing AI+ML mechanisms, and then passes them to data engineer, to myself, to be embedded. And like we will be showing in a second, he audits the trained models and the training data sets that he receives from the factory in order to define the efficiency and the potential for the improvement of the mechanisms he is deploying in our productive solution. So at this point, let me switch to my system. So already from the very system screen, you see that we have a number of dashboards here. Those dashboards are the built-in functionality of IRIS, and you can build similar dashboards yourselves. Here we're just using something coming from the template, but basically they are modifiable according to your needs anytime. This dashboard is showing us how well our modeling stack is performing, and we see that we are approaching some problematic area because the percentage of wrong classifications by the modeling stack is approaching 1. So soon we'll be probably facing the need to retrain the model. We have also another panel of dashboards that is showing us the state of our training data set. So here it's important to mention that our solution is applying a reinforcement learning approach. So that means we don't have a sufficient data set, sufficient to immediately train models and apply them as decision supporters. We had some very limited volume of information, some very limited number of examples in the very beginning of the functioning of this prototype, but gradually you can see it through that dashboard in the upper left corner. It has been fishing out from the, if I can use this term, from the stream of the data coming through the running history of equipment. It's been able to catch some similar records, put them next to the initial volume of training information. And then there are a number of rules that are scrutinizing permanently those label suspects, I would say, in order to assess their right to stay in the training data sets dynamically. So the composition of the training data set is managed by the solution itself, and this management is reinforcement learning. So anything through the more we get to know the behavior of our equipment, the more different the training set becomes. All right, so that's the reinforcement learning element in this solution. And finally, we have also a set of dashboards that allow us to control the incoming physical parameters of the equipment. And the equipment here is a feed pump. This is an industry level industrial pump that is frequently used in power generation or in heavy manufacturing, in extraction industries, and so on. And usually such pumps are well equipped with sensors. So in this particular case, we had a history, per second history of 10 months of functioning of a specific pump, and those 10 months, this heroic piece of equipment has gone through a number of troublesome situations. So we have quite a good set of data to flow into our prototype and to make the prototype actually detect whether we are approaching some alarm situation or not. What's also important here is that we have, let me start from showing this. So we have, like I mentioned, we have a system of processes. So there is a generator process that works with the equipment. There is a buffer process that organizes the queues that we've mentioned in the slide. There is the most important process called analyzer that is doing the analysis and also administers the training or retraining attempts. And there is a monitor that is monitoring the quality of modeling. So those four processes are sort of the core family of process in that solution. And that's its functioning. We can observe through the queue monitor. We see that certain of them are working on their own. Some of them have passed control to Python. In this case, there's a so-called Python operation, the interface of interoperability with Python. There are several of them, but we'll touch on it later. So in order to now enable our data scientist Eduard to audit what's happening here, I need to transfer to him a copy of the latest training data set so he could repeat, sort of imitate alternative training on this data set on his end. And we will be using Microsoft Azure in order to transfer the data, and then to Eduard will be using Microsoft Azure ML to run something in parallel to what we have in IRIS. And I, on my end, to make a double check, I'll be running integrated ML with H2O stack behind to also audit the current implementation of the handmade stack of models in this prototype. So let me start by actually running the data transfer process to Azure. So I'm doing it by sending it a triggering message. So we will let it signal me that everything is going good, and now would like to visualize its visual track. So while it is doing it, we can start actually looking at the composition of this process that I've started. Just let me, it's very close from actually finishing the initial launching, so just allow me several seconds. Okay, so take a look at its track. All right, so it's in progress. And while it's working, let me go to here. All right. So while what I've just monitored in the working folder of the prototype, I see that there is a retrain that is active. So it needs to finish before our data finish and produce the training data set, release it for actually sharing with the data scientist. Our process here, that I've just launched, it's waiting for it to stop. But while it is waiting and while they will be functioning, so let me quickly take you through actually the processes of the prototype. All right, so what I'll do, so while those guys are being executed, so I'll start with showing you probably immediately factory analyzer process. This is the major process here that I've been showing before, that is implementing the major functionality that we need in order to apply the models and to train the models. So there are certain steps that are executed once we launch the solution. So there is some cleanup, some housekeeping, there is some default parameters definition. Then the important action here is to load the necessary packages for the machine learning environments that we are orchestrating. And we are orchestrating in this prototype 3 environments. We have Python, we have certain portions executed in R, and we have certain portions executed in Julia. So for example, before anything starts, we need to load the necessary list of Python extensions. This is something that is specified here, and you can see that this is specified immediately in the process. So it's not somewhere externally stored script. It's just a part of this visual design of the process that we will further launch, and we actually that is working right now to be completely precise. And the same action has to be done on the Julia end. For R, we're not doing it because we're using base R. We don't need to load any additional packages, but for Python and Julia, we're doing it. All right. Let me quickly check what's going on here. Okay, still waiting, no problem. So what we are doing further in the process, and that's something that is working already, right? So we start the loop in which 2 modes of functioning of AI+ML mechanisms are being fired. So there is one that is called the training mode here, and the other one which is called ML scoring or application. We also call it application mode. So ML scoring applies the model that already exists, the model stack that exists. The training branch is doing the training, and if I open the training branch here, so I'll see a sequence of steps that are executed partially in Python. So I can, for example, I can go here and see that there is something that is being done with principal component analysis. There is a logistic regression that is being applied, probably reusing the principal components. And this is something that has been created by the data scientist for me. So I have quite basic knowledge theoretically. Of course, I know it by heart. But and then certain portions of this process are being executed in R. So we can see some R commands that probably are dealing with visualization of the results. We think it's more convenient to visualize certain things using R. So this way, as you can see, and in between the code in Python and R, there are elements like, for example, initial model build, so we can verify whether there is an initial version of model provided in principle. Is it needed, yes or no? So if not, if false, then we continue applying the model versions that have been trained and which are functioning. If the retrain is needed, and that's something that is all right, the retrain has finished, so I'm finishing my quick excursion here. So then we start training. Let me because now let me go here. My transfer to Azure has been started. Okay, so that's good. I'm waiting for it to do its job, and then I'll be able to trigger Eduard's actions. So Eduard, 1 minute patience, please. And while we're looking at it here, just a second, I would like also to comment on the Azure transferring process. So this is the one that I've just launched. And this one is basically quite simple. It's wait till its turn opens up. So it's checking the logs. and when he has a possibility, he kicks in and just basically loads the available content from the training data set queue into Azure, and that's it. Then he's doing some housekeeping in Azure and lets the other processes actually function. All right. So so if I now get back to the visual trace, still working, good. So this way we implement Azure. The first step in Azure audit, that means I have to throw the data to the cloud, but also right after this transfer is finished, I'll be also doing my own kind of audit on my end, and I will not be going to cloud. I'll be using our integrated ML functionality. That is basically it's SQL script that makes working the powerful H2O engine behind the scenes. And then when this is finished on my end, and when Eduard is finishing his part, which I hope will start happening in a second, we can compare the results, Azure versus H2O, and draw some conclusions. So I'm checking. All right, that's finished on the Azure side, and just to check this, just to make sure that this is happened. Let me. All right, I think Eduard, you can start actually your end on your end. So I think it's very it's okay. I'll just launch while you are showing. I'll launch on my end the Azure portal, and we can see all the progress of my actions and your actions. But you can take the screen from me and proceed with your audit, please.
Okay, I'll start. I'm showing my screen, and I'm launching my process. So let me just launch it first, and after that we talk about what was actually launched. So to get back to the presentation, we've distributed AI+ML. Yeah, let's talk about that. But first of all, the separation of workspaces between data engineer and data scientists. They have, well, of course, they have the same goal to make their AI+ML solution work, but they go about it in different ways, and they control different part of the process. Data scientists does exploratory work. There is a lot of experimentation, and sometimes it could even be research in some advanced cases. A data engineer, on the other hand, is more concerned with running already built models or scripts in production, so they run every time. And it makes sense that they're separated. Another case is, of course, the law and various regulations. If you need to build a model based on personal data, giving it to someone from external organization is usually forbidden for law and business reasons and ethical reasons, of course. So the data scientists from another company or from another part of your organization might not have access to the data. This way, in our example, we are showing the transfer only for some part of the data. Let me bring you the next slide. Yes, as a part of what distributed AI+ML is, where we have various machines for training and for running predictive models, AI+ML models. Our machines differ. For example, data scientists can have one interface, and we could have a build server with graphic cards for fast and efficient building of models. On the other hand, local instances deployed, well, in our example, in factory, but well, on premises may have less of an environment, and they're only geared towards running predictions. So, or if, for example, we are talking about neural networks which can be trained in parts, the main part of a training could be carried out on a centralized instance, especially if we're talking about image detection. For example, if we are doing image detection on medical imaginary, the model must be trained on the specific piece of equipment which we would want to predict for, or at the very least, if we cannot, if we don't have enough data to train the model for each piece of equipment, at least it should be a small subset of closely related equipment which was in production in the same area for around the same time, because the physical differences between new and older equipment for imaginary and stuff like that, it really affects the photographs they made, and it affects the data piped for AI/ML models. So we can do initial training on a centralized instance and a final step of a training with local instances with local data. Here you can see we can use TensorFlow, PyTorch, and actually all other libraries available in Python, Azure. There is complete, there are no stops or anything. You can just use your preferred way of building the AI/ML model. For the transfer of the data, in our example, we are using Azure Cloud, and I would actually be using Azure machine learning capabilities, but we also support AWS, Google Cloud, and actually you can go without cloud at all if you want to. So you can transfer the data through your local network and not upload it on a third party's resources. That's also fine. Just an example we wanted to show you today. And let's get back to the process. Let's see how well it goes. It should have been started, yes. And
Eduard, just to say, sorry, factory here. Can I take for a second a screen from you just to show to our audience that we have transferred that data to Azure?
Right. I think we've started the job for Azure. Can you see it on your end?
Yeah. Wait a sec. I'm checking. Okay,
take
so
the screen.
I'm taking the screen from you. So, so first of all, let me show you. I'm now in the Azure portal, and I see that there is the dump, the data portion available as a current state of the training data set has been placed on Azure. So it's today's timestamp, and the time reading is 2 hours plus the Central European time. So it's 8 minutes ago, the data was there, and Eduard, that has started the audit on his end, is working with that data. This is one piece of information. So the second one is that, like I've promised, I've started and already finished actually doing the audit on my end locally on the factory using integrated ML with H2O behind it. So this is already finished, and I'll show you the results when Eduard's results are ready, so we can compare them. And now I'll get back to the machine learning portal of Azure, and this is the last yesterday's run here, number 52. There's yesterday's timestamp. So let me refresh. All right, we can see that the timestamp is now today. This is the current timestamp, your Central European time plus 2 hours. And we have the latest run, number 53, that has been initiated on from remotely, externally by Eduard. Let me visit quickly this one. So we see that this is his job is now queued on Microsoft end. So waiting for it to be executed. Ed, I return to you the screen if you could provide maybe some comments on how your auditing process works.
Okay, let's go into a process or into auditing process. We're now seeing how it is being run, but let's see what's inside. It's the same interface. First, we're loading Python modules, and after that, we're loading into Azure. Let me show you. Yeah, here it is. What I wanted to show you, I guess, is the part of a process. Actually, this part. So first of all, what I wanted to show you is variable substitution in our activities. So in here, I'm referring the process. If you're familiar with interoperability, our business processes are actually all just a second. Yeah, we're back on screen. Our business process and actually all business hosts have properties configurable from production configuration page. And if we see our process, it has here some ML settings, which are Python operation, which is a reference to community gateway, and work directory, which is the directory where we store the files related to the work of this process. And from the business process itself, we can refer to it in this variable substitution way. And when we send the data to Python, it would be replaced with the actual values. So this way we can easily transfer work between different environments. I'll show you it here. Yeah, you can see that in a business process we are sending the variable, and in Visual Trace you see the Python gets the exact path value. We are still waiting for the.
It's in progress. It's running. I can see it on my end.
Okay.
In Azure.
Okay.
So
the second part which I wanted to showcase is data. For data science work, it's very important to load large amount of data as its tables. So first of all, here, for example, we're sending data from InterSystems IRIS into Python, where we just need to write an SQL query or specify a class name or a table name or a global name. And we need to specify which variable in Python, on the Python side, we want to fill with the result, and the type. For Python, the type 95% of time is a data frame, pandas data frame, which we want in this particular situation, and it's a really good default. And we have this.
Eduard, sorry, factory here. The processing on the Azure side is finished. So once you are comfortable, please, you can check the visual log, just for you to know.
Okay. Thank you. Yes. So that's flow of data from InterSystems IRIS into Python, and the flow back here. Let me show you. Is actually the same. We can query Python pandas data frames. So you can see here I'm calling pandas data frame, which is essentially a table, and it's in memory, of course, and I from this select query insert into a stable permanent storage on InterSystems IRIS side. So the bidirectional transfer of data with just SQL queries is possible with this community Python gateway. Let's see if our Visual Trace has progressed. Yeah, now we got the data back from Azure, and we're the were a curve graph. Let's wait a bit. It should be finished soon. I was also working with integrated ML. Final step is resource cleanup, where we delete the resources we provisioned on Azure, which were used to compute the ML model on Azure side. Don't forget to delete these resources after you're done with your work. It's very important. Let's see, visual trace. I think there is a
maybe some visuals are already there. Can we check in your file system? Maybe there's already some nice graphs. Not yet. Let's wait. It's 20.
It's an old one, but let's. Oh, we actually have one newer output. Yeah, let's see that. It's a log from Azure, which we got, where it states what was happening, and well, everything was successful this time, so it's not really that interesting for us, except maybe the results. But if something went wrong, it would be of a more particular interest, I guess. To get back to our
takes a while.
Distributed ML, which is becoming more and more popular, and in many cases becomes the only way you can do AI/ML at scale. We are showing you this example today with only 2 nodes of a factory, which is kind of an edge, and the data scientist, which is also kind of like the dev testing environment. But of course, the distribution can be much larger at scale, with every facility or having the independent, well, semi-independent instance. We talked about why that happened. One other actually advantage of computing AI/ML at the edge is latency, because if you have your interference in place, it would always happen faster, simply because it lacks HTTP lag, so you can produce predictions in the same second or with whatever frequency you need. That's also could be an important consideration in many cases. Let's see once again if we are, yeah, we're done. And now you see that graphics is a new one. Here we compare the Azure and IRIS accuracy, and you see that IRIS has slightly better one on this data. Okay, and how's your results with integrated ML?
That's curious. What do you have, Eduard? You obtained 0.98 versus 0.96, right, on Azure side. Yeah. Can I take your screen?
Yes, please.
Yes. So switching to my screen. So first of all, just what I'm showing right now is the completed status of the job on the Azure cloud. And actually, I knew his result before he announced it. Sorry, Ed. But what I'd like to show is also the result that came from doing the same kind of audit with integrated ML, and here we had a slightly better result on H2O than IRIS. So we have Azure, then IRIS, and H2O has been the best. If not 3 of them are the overfits, by the way. So that's also the probability we have to be careful. So we see. So I think what would you conclude as a data scientist, Eduard? Are we okay?
We are. We might actually use all the 3 models and check that they're up to date, produce actionable results, and maybe have a triumvirate ensemble of these models.
Good. Factory passed the audit. Thank you. We'll just finalize this presentation that we've probably run several minutes beyond our time budget, but we'll go quick. And what we wanted to show as a kind of conclusion is that the mechanisms that you have seen in that typic factory that can be applied to any industry, we would like to make a quick bridge to one of the prototypes we've been doing for the healthcare industry, actually the focus industry of today's event. And in the slide that I'm showing, we are showing you the, let's say, so the brief composition of the prototype that has been built for one of the groups of hospitals actually treating a rather intensive flow of COVID patients, with those patients connected to medical machinery, and the observations of their physical and partially chemical parameters is being received in real time. So in this prototype, we were tasked to predict the change in Horowitz index. The Horowitz index is a lung functioning metric that is very important in actually in managing your intensive care unit that is treating a huge volume of COVID patients, because it tells you immediately how well, in principle, this or that patient is progressing. So the day-ahead forecast is a really useful piece of information that those medical specialists can use to optimize the working of their staff in the ICU intensive care unit. So here you see that we used the IRIS platform to read in this data from real life people, anonymized, of course. And in the right part of the slide, you can see the prediction and the actual that was measured one day after for Horowitz index. So you see that the change in Horowitz index per patient has been modeled, I would say, at a reasonably good level for the operating staff to discriminate between light cases, medium cases, and the cases that would require concentration upon. I guess that was all on our side. Johan, how do you think? Could we take some questions now?
Yes. Hello back. Spasibo, Sergey, Eduard, for this really thank you for this very impressive and amazing presentation we've heard, and I really like the way you push and pull the screen back, forth, right, left, and play with the production. And it was interesting how smooth and seamless everything works for me as well. Yeah, we do have a couple of questions that occurred. First of all, I would just place it to you both. So one of the questions was, where can we download and try the AI and ML functions that you've shown in your demonstration?
I'll take this one. So integrated ML, which is a part of IRIS, you can download on, well, from VRC, from container registry of InterSystems. It's 2020.3. The Python Gateway, RJ Gateway, and Julia Gateway we showcased today are community projects which are available on OpenExchange, the catalog of InterSystems open source project made by community, and these projects are made by community too. You can write us an email at mltoolkit@intersystems.com to get access to the collaborative group where you can discuss ideas and get the latest demos, technology examples, and similar things. And there is a public Convergent analytics GitHub repository, where is also a list of materials, learning materials, webinars, articles in several languages, including English and German.
Okay, thank you. So another question, from your point of view, what is the best way to start implementation in our business scenarios using AI and ML with IRIS? What do you recommend the best way to start to implement?
Oh, great question, actually. So I think, first of all, I'd like to recommend you to go to the Kena software session next week, because that's exactly what we would be talking about all the sessions. So they're a company with no experience in AML initially, but they really needed to build AML into their product, because it was actually the core part of master data management with duplicate detection, and they've done it. So, and they would talk about their journey to AML. That's really what I would recommend. But in short, you need to choose or search for a case which is, first of all, simple, and not like very experimental, and second of all, which contains provable and considerable value to your business. So choosing the use case for which you would go forward is the most important initial step on your AML journey, I think.
Yeah, great advice. Thank you. We do have another one. Who uses the ML toolkit in production already? Can you name?
Let me pick this one. We mentioned already Kano Software, which is our partner, but also working, representing InterSystems technology within their solutions in front of their customers. So they have embedded the functionality you've seen today in their solution. And that's a master data management solution that applies certain machine learning on the fly to, for example, do some data cleansing and data matching. But there are also final customers, one of which is our kind of public example since already more than a year, if I'm not mistaken. And I would like to mention the group of Spar supermarkets, Spar, that is the biggest internationally, the most widely internationally spread network of supermarkets that is using productively these instruments for their machine learning tasks.
Okay, cool. And
that's just two examples for the moment.
Sorry?
Just giving two examples, but of course there's more of them.
Yeah. I do have a valid question, I think. What requirements, skills do I have to fulfill to be part of the mentioned community?
If we get back to Convergent analytics community topic, so then what you've seen today is a kind of a collective effort of quite a number of people that are the members internally and externally in the community. And for the external people, for our valued partners and customers, we would recommend actually visiting the first link that you see in the bottom slide, in the bottom part of the slide that I'm projecting here. Hope it will be available as a video at least. And there you have all the necessary guidelines to download and set up your own landscape completely so free, both financially and also time-wise, to start practicing on a modest scale the things that we are discussing here. There's also the contact email and also the basic version of documentation. For those that are more interested in particularly ML toolkit, like Eduard was mentioning, we have a possibility to join you on the more narrow circle, so to speak, of the people that are already have their hands on that. So this is the first path. And for the colleagues, the internal folks, just contact us directly with myself and Eduard. We will be happy to join you in. So there's no formal requirement on knowledge. At least the people that are on the internal part of the community, they represent all the thinkable departments of InterSystems. But what is really important is your motivation to pursue the in-platform AI/ML topics, which means that you need to be morally prepared that the classical AI/ML approaches taught in most of the universities are no longer working here, and we are sort of taking you into another universe of running it in a productive mode. That motivation is the most important, I would say, Johan.
Great, thank you. And we were that precise on time. I would like to say thank you again for the presentation, and I switch over to German to say auf Wiedersehen, und wir sehen uns, wenn Sie möchten, 13:30 Uhr geht es hier weiter mit der Präsentation meines Kollegen Amir Samari, und ich freue mich auf ein Wiedersehen. Machen Sie es gut, Wiederschauen.
Bye, everyone.